the relationship between two different charges, specifically the electrostatic force between them. That relationship is known as Coulombs law. So Fe, force electrostatic, is equal to K, which is our electrostatic constant, multiplied by Q1 times Q2, which is over the distance between those charges, which we represent with R, squared. So Q1 and Q2 are our two charges. We are first going to look at the distance between them and then the size of those charges. So the size of the charge is a direct impact on force. As we see, it's in the top part of our equation. So if one of those charges were to double, for say, our force would double. The distance between them, though, we see is on the bottom portion of our equation, and it's squared. So what that really tells us is the force is going to increase a lot, exponentially, when that distance is close, and it's going to diminish rapidly when that distance becomes bigger. Now, it's important to note here that K, our electrostatic constant, 8.99 times 10 to the 9th power. So it's a very large number because electrostatic forces are very strong forces in comparison to something like gravity. And the units on that constant is newtons times meters squared over coulombs squared. And so what that inevitably does is that newtons factor in the constant will cancel the meters squared from the r squared on the bottom, and the coulomb squared on the bottom will cancel with the charge times the charge on the top of our equation. And newtons is the only thing left over, which is great because we are measuring an electrostatic force. So if I get a positive value, that means I have a positive Q and a positive Q getting multiplied together, or I have a negative Q and a negative Q getting multiplied together. So any positive value is going to be for charges that are repelling. But any combination of a negative and a positive for Q1 and Q2 would give me a negative answer, and that is going to indicate that I have attraction between those charges. So if I pay close attention to those charges and include them in my math, the numerical value, the sign on the electrostatic force in the end will also indicate if there's repulsion or attraction. A question that sometimes comes up is, well, there's two charges, but there's one Fe. Why is that the case? Well, because those charges are putting forces on each other. So yet again, Newton's third law is here at play. Whether it's attracting or repelling, those charges are pushing on each other and they have no choice. We know that those forces will be equal in size and opposite direction.